Hi, welcome to week 6 of software engineering. This is Alessio. This week we're going to look at testing. Testing is probably one of the things that we have to do. Not the most exciting unless you really love testing, but overall an extremely important thing in software engineering, something that we cannot go by without thinking about it. There is one truth in the world. That one truth is that we have to produce things. We have to make sure that they run. We can't just hope for the best. And that's what we have to do. We need to make sure that things get up and running. So unfortunately, or fortunately, today we talk about validation. Validation is testing and testing is validation. Testing is an example of a more general process called validation. The purpose of validation is to uncover problems in a program and thereby increase your confidence in the program's correctness. Validation includes the formal reasoning, code review, and testing. So overall, why are we looking at this? Because testing will be extremely important in the industry. When you work on your own, when you do your own things, when you are hacking over the weekend, you probably never care about testing. It's the last thing that you probably want to do. You just want to have fun. But when you get to a real job, to a real position, to the profession, you will realize that testing is by far one of the most important things that you can do. Because, as I always say, this is one thing which relates directly to revenue and the God Almighty dollar sign. So, the first thing, formal reasoning. Formal reasoning about a program is usually called verification. Verification constructs a formal proof that a program is correct. Verification is tedious to do by hand, and automated tool support for verification is still an active area of research. Nevertheless, small crucial pieces of a program may be formally verified, such as the scheduler in an operating system, or the bytecode interpreter in a virtual machine, or the file system in an operating system. The second way is the code review. Code review is probably one of the things which I do enjoy about testing, because code reviews not only allows you to learn from people who are doing the code reviews for you, it's a very good social tool. Having somebody else carefully read your code and reason informally about it can be a good way to uncover bugs. It's much like having somebody else proofread an essay that you have written. We'll talk more about the code review in the next reading, but for now, keep those 5 factors in mind. In a good code review, we'll look at consistency, simplicity, design patterns, code level implications, and quality of tests and documentation. These are really the 5 things that we look for. Finally, we have testing, the actual testing, the actual get down to your code and write it. Software testing is an organizational process within software development in which business critical software is verified for correctness, quality, and performance. Software testing is used to ensure that expected business systems and product features behave correctly as expected. So it is not always just about whether or not your function can do what is expected to do. Let's imagine that you're doing a sum function which takes 2 numbers and adds them up. Let's say that, for correctness it does work. It takes the 2 numbers and returns you the sum. But how long does it also take? So when you do run tests, we will also find very often that you actually count in milliseconds, or nanoseconds, or microseconds, some sort of second or very small metric system to find out actually how long that function took. And that's where we look at the performance. So software testing may either be a manual or an automated process. Manual software testing is led by a team of individuals who will manually operate a software product and ensure that it behaves as expected. Automated software testing, instead, is composed of many different tools which have varying capabilities, ranging from isolated code correctness, checks for simulating a full human-driven manual testing experience. So this is instead where we program a machine to test the code. So what are the benefits of actual software testing? Software testing will save an organization time and money by reducing software development and maintenance costs. Software testing builds stability guarantees into the development of new features. Testing ensures that a feature is working as expected and users are not encountering bugs. Development time on a new feature is reduced by specifying a set of test cases that the new feature must match to be considered complete and deliverable. This gives developers a fixed target to work towards, enabling more accurate timeline estimates and lowering the introduction of new bugs. Once these test cases are in place, the overall maintenance costs are lowered. These tests can be run against an already delivered feature to ensure that it still behaves as expected. Now, this is a lot of writing and words, but what do we mean by this? Very simply, when we develop code, when we develop software, we probably expect changes to be made in the future. Changes can happen at any time. It could be because of our client, it could be because of things that we want to do, or it could be for third-party systems that we tend to use very often. Actually, we can probably say that more than 90% of the code that we write will be by 90% based on external modules. So every time you do your npm install, you are getting somebody else's code. And this year, you probably expect that to work. But what happens when next year somebody else makes an update on it? Is that going to break your system? How is your system going to behave? So there are many ways of looking at this, and it's probably something that you will look in the future as well. One thing that we look at is, first of all, avoid the system from exploiting, from just saying, hey, I'm broken. So there are things that we can do. One is to try and avoid that. The second one is to try and monitor so that when things actually do happen, we react as quickly as possible. The third way is to try and avoid total fail and degrade the system instead. Let's say that instead of going full boom, the system is just running more slow. That's one way that we can try to avoid these things. So that's what testing should try to do. What types of testing are there? When we talk about testing, there are many types of testing that we have to do, and they all tell us a story. There are fundamental levels within software testing, each examining the software functionality from a unique vantage point within the development process. Let's take a look at each type of testing in turn and examine its practical use. So you can see from the picture that we have a number of them. We have the unit testing, we have integration test, we have the functional test, we have the exploratory test, which we're not really going to touch. We are very much interested in three of them today. We're interested in the unit testing, in the integration testing, and the end-to-end testing. So let's start with the unit testing, and let's understand what a unit is. I believe that there are a lot of people who still do not really understand what a unit is. So let's understand that. Unit testing is a practice of instrumenting input and output correctness checks for individual units of code. The measurement unit, in this case, is a standalone code function or method. So the unit is the smallest part of code which is actually doing something. For example, this function here, the function sum int a int b return a plus b. We can say that this encapsulates the input and the output. Something happens in between. Now in this case, doesn't really happen in between because we're doing everything in like one line. But this is a complete unit because it is well defined, it has an input, it has an output, so we know exactly how it should behave. So we can say with confidence that this is one complete unit. During unit testing, production code functions are executed in a test environment with simulated input. The output of the function is then compared against the expected output for that input. If the output matches the expected test phases, then it's going well. If not, it is a fail. Unit tests are a great way to validate derived data functions. So let's think about the simplest form of test. Let's say that we want to do a function that does the sum, like the one we saw in the previous slide. It's very simple. We just do sum, first variable, the second variable. So we know that's simple. So how do we verify that? We know by creating an environment. In our case, the environment is the actual test. So, and we have it here on the side. So if the sum of 2 and 4 is not equal 6, then throw an error. So 6 is the result that we are expecting. And we expect it when we do what? When we do 2 plus 4, or we do 3 plus 3, or 1 plus 5, or 5 plus 1. You get the drift. So this is one way of running the test. Testing is about what goes bad and not what goes right. So as you test, you need to make sure that you actually try to test for what should go wrong. For example, what could be something that could go wrong in here? What if somebody, instead of putting in an integer, put in a decimal? If you remember, the way we wrote it in the previous slide, it said that it was going to be int a and int b. So already that should trigger an alarm. That's already one thing. Perhaps, because it's a decimal, it's still a number, perhaps we can try to manage it somehow. The second part is instead, what if we send in no numbers at all? What happens in that case? How will the system react? Or what if we send in, I don't know, a character, or maybe a word, or a string, or a true or false, or a boolean? So you can see that there are many ways to make this function fail. Next part, integration testing. So when software test cases covers more than one unit, it is considered an integration test. When developing a software test case, the lines between unit tests can quickly evolve into integration tests. Oftentimes, a unit test may be developed and operate against a third-party code dependency. So we mentioned before, probably 90% of code nowadays is external dependencies. The dependency itself will not need to be tested again, and the integration to it will be mocked up or faked up. So what does that mean? Let's go again into this. An integration test is a larger test. We still know exactly what the inputs are and the outputs are, but we're testing that the whole story does work, because one unit may provide us with one because one test may provide us with one result, which then flows into another unit, which then flows into another unit. So if we do not have an integration test, how do we know whether or not the whole system is working? How do we find out? So that's why we do the integration test. We test the whole environment with all the units that make that integration. Then finally, we have the end-to-end testing. Test cases that simulate a full user level experience are called functional tests or end-to-end tests. End-to-end tests use tools that simulate real human behavior. Common steps in an end-to-end test. Let's say that you have created a website. What is an end-to-end test? The user will click the button, will read the text, and submit the form. That is an end-to-end test. And what we normally do is we actually use a machine to do this. So we'll have a function that say go and click here, or simulate or emulate a click, and then follow everything up. Once again, the difference between what we had before and now is that right now we are not just thinking about variables, but we're thinking about how will the user actually use this. So we are actually thinking about what will happen when the user touches this. So that's a little bit different. Also because you don't always know how the user will react. And very often this is the basic error that happens, is that a lot of people forget to put buttons on. It might happen that you don't have a sign up button for a website that you were supposed to build. And then you have everything working and then you release it just to realize that no customer can actually log in because no sign up button was ever actually added, because nobody went out and tested it, because developers kept on using their developer account. So because of the full experience execution context, end-to-end tests verify correctness across all layers of the software stack. So it's time to put your tester hat on. It's time to be the bad guy. We're joking when we say this. Testing is not fun. We try to joke about it. But the reality of things is testing requires having the right attitude. When you're coding, your goal is to make the program work. But as a tester, you actually want it to fail. Your job is to try and make it fail. Not failing is a different story, but your job is to try and make it fail. That's a subtle but important difference. It is all too tempting to treat code that you just written as a precious thing, a fragile eggshell, and test it very lightly just to see if it works. This is what happens all the time with developers. They don't try to kill their own code because they write it in a way that they know it works. But when things change, then that's where you don't want to be when you're in a client meeting and you haven't tested your code properly. So testers is a hard job because you have to be the bad guy. It's your job to actually make sure that you test it so hard that you break it. You need to find ways to break it. And good testers are the ones which are the most brutal. Testing is not saying well done. As I said, you have to be brutal. A good tester wields a sledgehammer and beats the program everywhere it might be vulnerable, so that those vulnerabilities can be eliminated. A tester has the heart of a developer in a jar. I like this one. In a jar on the desk. Yes, I actually love this one. So why is this so damn important? If you remember from the second lesson, we were talking about good code and what depends on us. It's not always just your simple bank application or your eBay page or these kind of things. You might actually be working on developing the software to keep aeroplanes afloat or to hooked up to somebody's heart machine. What happens if there's a bug? The person might actually die, or maybe the plane will crash. So we really want to be sure that the software is perfect. No need for testing is not a sign of good development skills. Testing is not about being good at writing software, but being ready for the future. Good test means that the person coming after you will not need to worry about what you wrote. This is the thing. So if I inherit somebody's code, I need to make sure that whatever happens, that code will work. If I go and add a new feature, I will be able to find out straight away what happened. Why is my new feature not working? So do your test. It's what it is about. It is about making sure that your application is ready for the future. So sometimes it's hard. Sometimes you are tight for time. Sometimes you're just feeling lazy. These are the reasons why things fail. So test-first programming. This is another way of doing things. Test early and often. Don't leave testing until the end when you have a big pile of unvalidated code. Leaving testing until the end only makes debugging longer and more painful because bugs may be anywhere in your code. It's far more pleasant to test your code as you develop it, which is why we're going to talk about test-driven development. In test-first programming, you write a test before you even write any code. The development of a single function proceeds in this order. You write a specification for the function, you write the test that exercise the specification, and then you actually go and write the actual code. Once your code passes the test you wrote, you are done. So let's write a specification. The specification describes the input and the output behavior of the function. It gives the types of the parameters and any additional constraints on them. For example, the square root parameter must be non-negative. It also gives the type of the return value and how the return value relates to the input. In code, the specification consists of the method signature and the comment above if that describes what it does. We'll have much more to say about these specifications in a few classes from now. So let's have a look just at the code. So this is an example of a specification. This function returns the sum of two numbers. This is a clear specification. This is what this function will have to do. So you write your instructions first. And you can say that the sum is the name, and you need the two parameters, which is a and b. So then you write the test before you do anything else. So let's try to write the test now. If sum 2 and 4 not equals 6, then throw an error. So what is going to happen now? What if you run the code now? What if you pass in 2 and 4? What is the first thing that's going to happen? Well, nothing is going to return because this function is not going to return anything. So you already know that there is an error because it's not returning anything. Then the next part that you can do is you actually go and write the actual code. So running tests first is a good way to understand the specification. The specification can be buggy too, or incorrect, incomplete, ambiguous, missing corner cases. Trying to write tests can uncover those problems early, before you waste the time running an implementation of a buggy specification. So if you're running a formula and you write down all the specification, you can find out if there's a problem with that formula. That's one thing that allows us to not waste time, to save on the dollar signs by not spending time in doing things which are useless. Don't be nice or you will fail at being good. This is basically the mantra for being a tester. It's a job. It's an actual job. So being nice, telling a person, hey, your code could be improved, or no, you can say, your code is wrong, fix it here. This is a bug. This is where it breaks. So there's no way, there's no other way. Just, take that person's heart and keep it in a jar on top of your desk. That's your job as a tester. Q&A engineers, for your own information, is actually an extremely well-paid job. So if you guys enjoy doing something that is extremely important, is perhaps maybe repetitive, but so critical, perhaps becoming a Q&A engineer is your future. Who knows? And we have some Q&A, and that's all. Thank you. Catch you next time.